and then we'll solve some problems. So we are on section 12.3. So we know that the acceleration is the rate of change of velocity, so that's given by dv dt. Okay, so the way of looking at A equals dv dt is to look at a plot of the velocity as a function of time, right? And the slope is, well, the slope of a curve which is yx curve is dy dx, right? That's the slope of the of slope at any point in time. So in this case, if you want to find the slope and the x-axis is time and the y-axis is velocity, then the slope is, let me try a different color for this. So say this is the curve. That curve represents how the motion is changing with time, the velocity is changing with time. So if you want to find the acceleration, all you have to do is you will find the slope of the curve, and then that means take the derivative. So that is dv dt at time t equals t0. So that will give you the acceleration. Okay. So if you see that the curve is flat, the velocity time curve is flat, then what's the acceleration?
Zero.
It's zero, because the change in velocity is zero at first function of time. Let's look at this in a different way. I'm going to rewrite this formula, A equals dv dt. I'm going to take the integral of that formula. Okay. So if I do that, then I get A dt equals integral dv, which is A dt equals, if the velocity changes from v1 to v2, then this is v2 minus v1. Okay, assume that the time goes from t1 to t2. So I'm going to try to show you what this A dt really means. For that, I need to draw a different curve. This is going to be the curve of acceleration as a function of time. Okay, so this is, let's say this is a curve for acceleration versus time. Then A dt, okay, is the same as A is like the A is the y-axis, dt is the x-axis. What is integral y dx? It's basically the area under the curve, right? Area under the curve. So if I want to find the velocity, I need to find the area under the curve. This is the area. So if the velocity here at this point is v1, and if the velocity at that point is v2, okay, v1 and v2, by the way, is not anywhere on the x or y axis. What is there on the y axis is acceleration, and what's on the x axis is the time. So the reason I'm writing v1 v2 is that's what is the velocity when you have time t equals t1. Okay, but that doesn't mean that the y-axis is actually v1 and v2. So if you want to find v2 minus v1, all you have to do is find the area under the curve at from t1 to t2. Okay, now for this curve, this is not I just drew some curve, but most of the times you'll have triangles and squares, and so it's very easy to compute the area. Yeah, question?
One thing Professor Butler showed me last semester that really stuck with me throughout these graphs was you know how you have the formula for velocity, you integrate that, and you got the formula for positioning, and you differentiate the formula for acceleration. You related that to the VT graph, and then the area under the curve, that's your formula for position. And then
I'm going to get there. I'm going to come to DSDT. A similar interpretation.
Professor?
Yeah.
So is that A of t or A minus t
Uh,
in the box, right? Yeah.
it is.
The AT gap.
I should probably put area under the graph AT. When you say AT, it really doesn't mean A minus T because, well, A has different units and time has different units, so you cannot subtract. So it's AT, it's just it's area under the, that's how you write y-x curve, right? So similarly, this is not A minus T, it's A versus T or. Okay, so one more thing before we start with problems. So other thing we have studied in this class before is V equals ds dt, where S is the position. So if you draw a plot of S versus t, and if you take the slope at, let's say, time t0, then that slope represents the velocity at time equals t0, right? So this is slope of graph. Okay, I'm going to write V versus T, just not to confuse it, V dash T. Okay, so the final thing is, let me look at this formula in a different way. Let me try to integrate the equation. So ds is V dt. I'm moving dt to the other side, taking the integral. ds is equals to uh, where s1 and s2 are the limits. s2 minus s1 is integral v dt v1 to v2. Okay, so just like the previous example, what we do is look at the vt graph. But this should be t1 and t2, not v1 and v2. So this is t1 and t2, and this part here is the area under the curve. So S2 minus S1, where S1 corresponds to the position at time t1, S2 is the position at time t2. It is not the y-axis, mind you, it's the y-axis is the velocity. So S2 minus S1 is area under the graph of V versus T from T1 to T2. So you'll see that the real power of this is when you have simple curves like triangles and trapezoids and rectangles, where it'd be super easy to find the area under the graph by just finding the area of that particular polygon, and you do not have to do the integral. Okay, some of the problems in the book will be you'll be given the plot of v versus t and told to find the distance covered. Okay, in that case, you have to use this knowledge to do this problem. So let's get started with problem. Before that, do you have any questions about this?
The sentence before that, the 190 box, you scroll up a little bit.
Up.
Should that be the graph of s versus t for velocity?
The top graph. It is s versus t.
Yeah, the one you wrote down. I was just
It's written as V.
Oh, my bad. Thanks. Good catch. Thank you. This should be s versus t. My bad. Anything else? Okay, so here is a problem for you. Okay, let me read it. The velocity time graph. Okay, not to confuse you, I'm going to write this as v versus t. V versus t graph of a car is shown below. Okay, so the velocity is constant for the first 40 seconds, and then it changes in a linear fashion from 40 to 80 seconds. The figure is not to scale, I'm sorry about that. You got to find the total distance covered, and you got to draw the acceleration time graph. Okay, so if you're given the velocity time plot, then you can, and you're told to find the distance, then the first thing you would ask yourself is, how is distance as related to the velocity? Right. Exactly. So I think what I'll do is from next week onwards, I will post these questions beforehand, so you can just take a printout if you want to, and then you can just start solving instead of spending time writing it. In fact, in future, I'll just pick book questions from the book. So I'll do it on a weekly basis. So I'll have all the notes, all the questions that I'm going to talk about for that whole week posted on Sunday by early. Well, give me Sunday to post them, and so you can print it and then just write. But I'm sorry about it for today. Okay, so we're going to find the distance traveled, and the way distance is related to velocity is v is ds dt, which means that v dt is ds, and this is straight from the formula I had written earlier. Okay, so if I want to find the distance traveled, which is s2 minus s1 is the distance covered. I do not need to know s1 and s2, I just need to find the distance covered from 0 all the way to 80 seconds. I need to find the area under the curve from t1 to t2. So in this case, I'm interested in going all the way from 0 to 80, right? So as you can see, that's the area under the curve. Let me say graph. But the area under that graph is made up of two simple shapes. One is a rectangle. I'm sorry, it looks like a square, but it's a rectangle because you can see it's 10 and 40. And another thing is a triangle, right? From 40 to 80. So this is going to be, what's the area of a rectangle? No, that's triangle. It's base times height, right? So it's going to be 40 times 10. 40 is the base and 10 is the height, plus the area of the triangle, which is, now it's half base times height. So half times the base, which is 80 minus 40 times 10. So that's 400 plus 200. So it will be 600 meters. So S2 minus S1 is 600 meters. So this is part 1. Part 2, I need to draw the acceleration time plot.
On our
On the quizzes, we don't have.
Or like, you have to do stuff back.
So there are two types of. There's going to be a quiz in the class from. I'll talk about it in a bit. But that's just going to be multiple choice mostly. So you don't have to show the work. But for the exams, term exams, and the final, yes, you do. In fact, if you just write the final answer, I have no way of figuring out if you just looked over your neighbor or you actually solved it. So you have to show the work. I would say just try to articulate whatever you're thinking. So the acceleration time graph. So the fact that, well, let me just try to write a relation between acceleration and velocity, and the reason I'm doing that is because I am given the velocity time plot, right? So acceleration is dv dt. So all I need to figure out is the slope of the vt graph in order to draw the at graph. So you can see that the slope is the rate of change of the quantity, that is in this case velocity as a function of time. You can see from 0 all the way to 40, the line is flat, which means that dv is 0, right? And although dt is non-zero, it's 0 to 40, dv is 0. So acceleration is going to be 0. So I'm going to draw 0. This is 0. Okay, so going from 40 to 80, you see that the acceleration changes uniformly. It's a straight line. It's a constant, and you're going to find what that constant value is. So for that, you need to know how to find the slope of a line. So this is a prereq. You need to know how to do this. It's basically if you have a straight line, if you know the coordinates of 2 points, then you can take the slope, right? Say y2 minus y1 divided by x2 minus x1. So in this case, it's going to be v2 minus v1. So v2, let's say that this is 0.2 and that is 0.1. Velocity at 2. Okay, let me write it here. v2 minus v1, t2 minus t1. So this is between. So the velocity at this point at 80 is going to be 0. The velocity at 40 is 10. Similarly, the time t2, where I computed v2 is going to be 80, and t1 is going to be 40. So it doesn't matter. You can take v2 to be 40, the point where you have 10 and 40, and you'll get the same answer. It doesn't matter. The slope is independent of how you choose v2 and v1. So this is going to give me, I think 10 divided by 40, that's 0.25. So negative 0.25. Yeah. So all I need to do to complete this is this line here, negative 0.25. So that's my AT curve just by looking at the VT curve. Now, in an exam, you want to show me how you did this. Just don't draw the curves. Especially, for example, I would be interested in knowing this value, how you got that value, how you reasoned out. If you just say that the velocity is constant and so the acceleration is 0, that's good point. But just don't draw that curve and say, I knew it, just by looking at the problem. That's because there's no way I can figure out what you are thinking in getting that. So please try to articulate what you're thinking. Don't just throw the final answer as much as possible. Any questions? Okay, so